So we have a 75-meter long train, and we can say that this is going to be delta x2. So this will be equal to 75 meters, and then delta x1 will be equal to 180 meters. This is the distance from the initial point of the train to the initial point of the front of the train to the worker on the railroad worker. So that'll be delta x sub 1 equals 180 meters. The speed when it reaches the railroad worker, it's going to be equal to v sub 1. This is going to be 18 meters per second. And then we know that the initial velocity is 0 meters per second. So in order to find the acceleration of this train, we need to say that v1 squared equals v initial squared plus 2a times delta x sub 1. We know that this is going to be equal to 0, so we can say that the acceleration is simply going to be velocity sub 1 squared divided by 2 delta x sub 1, and this is going to equal 18 squared divided by 2 times 180, and this is going to equal 0.90 meters per second squared. The question is asking us, what's the speed of the train? What's the speed of the train as it passes the railroad worker as the last car passes the railroad worker? So the speed of the train when it first reaches the worker is 18 meters per second, but it's still accelerating. So it's still accelerating for 75 meters before the last car reaches the worker. So we can say that v sub 2 squared is going to equal v sub 1 squared plus 2a delta x sub 2. And this means that velocity sub 2 is going to be equal to the square root of v sub 1 squared plus 2a delta x sub 2. And if we solve, we can say that this is going to be equal to 18 squared plus 2 times 0.9 times x sub 2. So this will be 75. All to the 1/2 power, and we find that the velocity of the train as the last car passes the worker is going to be equal to 21.42 meters per second. So this will be our final answer. That is the end of the solution. Thank you for watching.